So the way that this works is if you look at this function right here, if you choose different values of x and y, okay, and then you'll get back. So I'm gonna make a little table here to kind of show you what's going on here. So if x and y were both 0, well, that's not going to work because that would just be 0 in the denominator. So we won't try that one. Let's make y 1. Okay, so if x is 0 and y is 1, then let's see, that would be a 1 in the numerator. So that would be yi over 1. So that's just going to be, so that would be the vector, it's supposed to be a vector here. So that would be the vector 0, no, it'd be the vector 1, 0, right? Because I is the x component, and so I is the x component. Okay, so now what does that mean? So what that means is that right here, if we go to this point right here, 0, 1, which is up here. Okay, so let me do it on this separate chart right here. So if we go to this point right here, which is right there, 0, 1, then our vector should be pointing this way. Okay, and have magnitude, you would have a vector right here that's 1 in the direction 1, 0, which is pointing to the right. And so if you look at that, then right here, this one has it. So this one looks like it could be okay, and then this one also looks like it could be okay. But these ones, that doesn't point to the right, and that doesn't point to the right. So that means that this one's out and that one's out. Okay, so if we choose a different value, let's choose 1, 0. And see what happens there. So x is 1 and y is 0. So if you plug it into here, you're going to get 1j over 1. So that's just going to be the vector 0, 1. Okay, so that means that at this point, right here, which is 1, 0 right here, then you're going to have a vector that points that way. So straight up like that. Okay. This one points down, so that's not going to work. This one points up. So that means that this could be the answer. Or that's the only one that can be the answer, it looks like. And then to get other values, you would simply, to get other, little arrows here, you plug in different points. And here looks like they've plugged in an awful lot of number of points there. It's a huge number of points. Okay, so it is the one in the it is the one in the bottom right. This one right here. That's the answer, because that's the only one that matches those two, and it has to match all of them. So yeah, that's the only one it could be. Okay. Now, when you imagine this, what you should think about is what happens if, let me use a different color. So when you look at this, what you should consider is, now what's going to happen if I were to have, think of this as being fluid flow, for example. So like, for example, if I put something right here, what's going to happen to that? Well, this vector is going to take it to the right, and then as it comes here, you've got vectors that are going upwards. So it's going to flow upwards. It's just going to kind of flow along with that, right? Or if I start something right here, then it's going to kind of come along like this, and then vectors start pointing this way more, and then it's going to curve around like here, and end up going that way. Okay, so you get a curve that goes like that. So that's kind of how you should think of that. If I had a point here in this one, even though this is not the right answer, then this is going to start going like that, and you're just going to kind of curve around a bit. It's going to curve around. It's going to go around in a circle like that. okay? Just following the arrows at each point that it comes to. Yeah, and like I said, like as you can see here, if you start from different points, then you're going to get a different path. You start down here, it's going to go something like that. Okay, and so on. So that's essentially how you can think of that. Okay, let's look at number 2. Here, this is the same thing except it's 3 dimensions. So the same kind of approach, except now we have an X, Y, and a Z. This time, if we make them all 0, then we're going to get the vector 0, 0, 4. Okay, so that means that when you're at the origin, which is, I think, in the very middle of this, yeah, because here's 0, here's 0, here's 0. So you're somewhere in the middle of this, kind of hard to tell. Your vector should be pointing straight up, with parallel to the z-axis, and these don't, so that can't be it. This one could be it. This one, dang, I don't know. This one looks like you got vectors pointing down, so I don't think this one's it right here. Okay, so you could put in another value. Let's put in 0, 1, 0. Okay, so that one's going to be 0. That's going to be 0, 1, 4. Okay, so that's going to be pointing a little bit in the y direction. So if this is the y right here, and that's the x. Okay, so we're looking at 0, 0 in the z direction, 1 in the y direction, and well, the x direction is 0. Okay, so we're looking at those points there, and here it's going to be pointing a little bit out, a little bit in the y direction, but still mostly up. Which one do you guys think it is? This one or that one?
I think it's the top one.
The top one? I think you're right. Yeah, I think you're right. I think you're right, because if you go -1 here, let's say you go -2, then that's going to be 0, -2, 0, 4. So that's going to be pointing backwards, right? And these ones point backwards, whereas these ones are always pointing forward. Even though you're negative over here, these are pointing forward. That's wrong. So top left is the correct answer. Okay, so this is the one right here. Okay, let's go to the next one, number 3. Match the function with the graph. So again, it's the same. The same thing, except this one it's what we call the gradient vector field plot. So notice this is just a function in x and y. It's not a vector valued function. Okay, it's not a vector valued function. But what they're telling us here is to take the gradient, and then which one of these is it represents the gradient. Okay, so the gradient function, so it's going to be the partial of f with respect to x, and then the partial of f with respect to y. Okay, so let's see what's that. That's going to be 12 xy. Wait, 12 times x plus y. So you bring the 2 down, and then multiply this by the partial with respect to x, which is 1. So it's 12x plus y. And This one's also going to be 12 times x plus y. That's interesting. Didn't see that coming. Okay, so now, time to get a few values right here. And then over here, this is going to be the gradient. Okay, so if we go 0, 0, then that's going to be 0, 0. If we go 1, 0, that's going to be, if you put, so you put a 1 in for x and a 0 in for y, that's going to be 12, 12. And if you put a 0, 1, that's also going to be 12, 12. Okay, and 12, 12 points this way, in the same direction as the line y equals x. So, this is weird. Well, it looks like that it comes out to 5. So maybe we should put in, then what if we put in, what do we put in 0, 10? Not as a vector. What if you make x equal to 0 and y equal to 10?
Should get 600.
Whoa, really? You
I
put a
think.
10 in here? Oh, you get 100 and...
Oh, never mind. Yeah, 120.
Yeah, it's still really huge. Okay,
Oops.
so this looks like it could be it, right? Because these are going up like that, right? That looks like it could be okay. This one looks, these look like they're going straight up as you go up here, so that's not right. And these are weird too. And this one, I'm pointing more to the right, so I don't think that's right. Or is it? I think it's hard to tell. These should be pointing to the right. So anyways, I'm pretty sure this is the answer right here. Wait. No, what am I doing? That's not the answer. I already said that there's got problems right here. This is the answer right here. Yeah, for sure, this is the answer. Yeah, because these are both the same. So it's either, so all the arrows, okay, yeah, I got it now. All the arrows are going to either point that way or point that way. You're not going to have arrows pointing this way. This just can't happen. Because these are both the same. So they have to be pointing, the x and the y have to be the same. So you can either have arrow point that way or arrow point that way. Nothing else. So like you can't have these. You can't have any of those. This is like really weird because there's some, this is like, I don't know what this is. Okay, and then these, you can't have them pointing, you can't have them like almost horizontal. That's not allowed either. So this is the only way it's going to be. And then when they're right here, they're going to be, they kind of cancel each other out, so you get 0, 0. Okay, important concept here, and that is a vector field is conservative if it is the gradient of some scalar function. And such a function f, so this f right here is a potential function for this gradient field. Okay, so this gradient field came from this potential function. It's the gradient of this function. Okay, so this vector field is called conservative. Conservative. Okay. Number 4. At a time t equals 1, a particle is located at position 4, 3. If it moves in the velocity field, find its approximate location at time t equals 1.06. Okay, so what happened is here, this is a vector field, and this determines it's like a think of this as like a fluid flow. If you drop something into here, then it's going to flow in the direction that this fluid's flowing. Now at t=1, a particle is located at that position. So if we calculate f of 4,3, we will find the direction and the speed, or we could find what's called, this would be the velocity of the vector of any particle that's located at this point. Okay, so that's x times y, so that's 4 times 3 minus 2, and then y squared minus, so that's 9 minus 8. So that is 10, 1. Okay, that's like your velocity at that point. Okay, so this is the velocity, this is the direction it's headed. So it's currently located at it's currently located at 4,3. And we're going to let 0.06 seconds go by. And when it starts out, it's headed in this direction. This is the velocity right here. This vector represents the velocity of the particle when it starts out, when it's at 4,3. And it's going to continue going in roughly the same direction. I mean, it could curve a tiny bit, but it's roughly the same direction. So if you take 4,3 and you add 0.06 times 10^1 to it, then you're going to get roughly what it is, where it goes to. So that's going to be 4.6 and 3.06. So that's just going to be an estimate. Okay, and so yeah, so this would be the correct answer right here. This is to give you an idea of what it's like. This is like the tangent line equation. Well, it's actually from the tangent line equation, but it's like, or the linearization. It sort of is the linearization. Okay, so any questions about any of that?